Hey, this is a quiz review. All right, so let's go ahead and get started. This is for the polynomial functions. So you may use your notes and your homework on this quiz, and like always, do your best. Okay, keep in mind if you feel you did not do well on this quiz, you can retake it. All right, so here is the first question. So the first question, if you notice here, it only gives you the first part of the function. And that's all you kind of really need to figure out which graph goes with this function. So what I'm going to do here is I'm actually just going to do this one, okay? So here I notice I have a degree 2. Okay, and if I have a degree 2, then I can find out how many extreme points or the extrema. And that's just going to be the degree minus 1. So 2 minus 1 is going to be 1. So that means I have one extreme point. So the extreme points, like for example, this has 1, 2, 3, 4. That can't be it. 1, 2, 3. That one can't be it. This one has 2. Number 3 has 2. And number 6 has 1. So right here for number 6, I can see that it has 1. And for number 7, sorry, number 7 is kind of broken up. This one also has 1. This one has 1. Number 8 has 1, 2, 3. Okay? All right, so what I'm going to do now is I'm going to go up over here, and I have a degree 2 polynomial here. So now what I want to do is say, okay, well, if I have a degree 2, that means I have one extreme point, which left us with number 6 or number 7. So now we just look at the leading coefficient. Okay, this leading coefficient is positive. And when we have a positive leading coefficient, that means our polynomial, our end behavior, is going to face up on the right hand side. And because this is also a 2, I know this is an even function. So that means they face, or my end behaviors, are in the same direction. All right, so that means we're going to have the right hand side goes up. That means the left hand side also goes up. So that means I'm left with, if I'm going up, so here this one goes up, the right hand side goes up. So for this one, I would pick up this drawing and put it right here. Okay. So for your quiz, what I'm going to have you use is, you can use this, okay? So if you have a degree, like a degree 3 polynomial, so anything that's like odd, like 3, 5, 7, okay? That means it's going to be an odd function. The end behaviors are going to point in opposite directions. So if the right hand side goes up, the left hand side goes down. If the right hand side goes down, the left hand side goes up, opposite directions. Okay, and here they would face the same direction. These are the end behaviors. Okay, then you look at the leading coefficient. So let's say I'm going to the odds. Okay, then I say, okay, well, what is my leading coefficient? Let's say my leading coefficient is positive. That means the right hand side of my function is going to go up. If I have a negative coefficient, that means my right hand side is going to face down. So it's kind of like a little guide to help you. Okay, and then the number of extreme points here, the number of extrema is the degree of the polynomial minus 1. Okay, so I'll post this on your Schoology page. It'll be called, like the title that says up here, GO for Graphic Organizer Characteristics of Polynomials, just in case this does help you. Okay, so that's number 1, so you have to match it. So this is the next one. It says determine the degree. the leading coefficient, and the constant for each polynomial. Okay, so here, what is the degree of this polynomial? You're going to write it here. What is the leading coefficient of this polynomial and the constant? Same here. You're going to tell me the degree, the leading coefficient, and the constant. Okay, so next it says, what number is this one? Question 3. Use the leading coefficient test to describe the end behaviors of the polynomials shown below. Okay, so here remember we're looking at the end behaviors. Are they going to be in opposite or same direction? Okay, and here you have your options. So this is drop down. It's going to say like you could drop down and pick the correct one. This is just listed because it's printed. Okay, so here I'm going to look at the degree of the polynomial. So this one's a degree 4. So I'm going to go over here. Okay, and if we have a degree 4, that means we're going in the even direction. That means the behaviors are going to be the same. You're going to look at the leading coefficient and you're going to tell me if it's positive or negative. So this one, let's see, was over here is negative. Okay, the leading coefficient. So if it's negative, it's going to go here. That means the right-hand side is facing down, okay? All right, so that's going to help you with picking the correct ones here. Okay, so you're going to look at this first term. This first term kind of helps you out, okay, to pick the right one. Okay, question 4. Miguel identified the graph below as a polynomial function. This is the polynomial function where a, b, and c are positive. So he said, here we have negative. Remember, b is a positive, so that means it's negative 3 or negative 2, whatever. Okay, the graph is not a 4th degree polynomial. So is this going to be a 4th degree polynomial? Okay, it has 3 extrema. And remember, the degree of the polynomial is 1 minus this. So if it has a 4 here, I should have 1, 2, 3. Okay, the graph is an even function, but Miguel's polynomial is not even. Is this an even function? Are they facing the same direction? The leading coefficient of Miguel's polynomial should be negative. Should this a be negative? Should these guys be facing down? Are these guys facing down? And the y-intercept is below the x-axis, so Miguel's polynomial should end with negative c naught plus c. So here is where we have our y-intercept. Should be positive or negative. Okay, so just there's only one. So tell me why he is incorrect. Determine all the possible rational roots. Okay, so you have to do p over q. Use the correct p and which one is the q. Okay, so pick the right one using p over q. Okay, find the information shown below given the function, this guy right here, this function f of x. Okay, f of x has how many real zeros? So remember, you're using Descartes' rule of signs here. I'll write that in here as a hint. You're going to check the number of changes, okay? Then you're going to figure out f of negative x, and once you do f of negative x, then you count the changes, and that'll tell you how many negative zeros you should have. All right, for question 7, how should you factor this guy right here in factor form? So what is the factored form? Should you factor by grouping? Factor the difference of 2 cubes, use the rational zeros theorem, which should say the rational root theorem, or use Descartes' rule. How do you factor this? Okay, how would you factor that? And once you factor it, then what would you get? So just try factoring it first. and see if you can actually factor it this way. See if that's going to give you an answer. And if it does, what do you call this method? Factor by what? You have to find the correct one. Okay. Okay, here we have a true or false. There are 4 zeros in this equation. Is this true? There are no real solutions to this equation. Okay. Can you factor this? Maybe just try how you factored this number 7. See if you can factor this one the same to find any zeros. 1/4 is a possible rational zero for this equation, and here it says use the remainder theorem or the factor theorem. You can also use the possible rational root theorem, okay? There are 2 or 0 positive real roots for this equation. You can do that using Descartes' rule of signs, okay? You're just checking the positives, so you no need to do f of negative x here. True or false, okay? Here it says match each graph with the correct description. Okay, so I'm going to look at this last one here. This last one, if I see, I'm going to count how many extreme points it has. Okay, so this polynomial must have a positive leading coefficient. Should it have a leading positive coefficient based on the right-hand side? Okay, or should it? Okay, this polynomial must have a negative leading coefficient. Would this give it a negative right-hand side? Or is this polynomial must have a leading, a positive leading coefficient? And is this going to be an odd degree or an even degree? How many real zeros does it have? That means how many times does it cross this x-axis here? Okay, so you're just going to match these 3 with the correct graph, okay? And that's just pick it up and put it in the correct spot. Okay, so that's it for the quiz review. So go ahead and start your quiz. There will be a couple changes. For example, it's going to say what is the possible rational roots, and I'm going to put zeros in parentheses. There are no real solutions to this equation. Okay, so check by factoring. Okay. And this one I'm going to change this to hint, use the possible rational root theorem also. You can use the remainder theorem or the factor theorem also. Okay? All right, do your best and make sure you submit your quiz. Bye.